Number 51. The second derivative of a function h of x is given by h double prime of x equals x squared minus x minus 2 to the third times x minus 8 to the fifth. Of the following values of x, which of these does the graph of h of x have a point of inflection between 0, 2, and 8? So this brings to light an idea called multiplicity, and it has to do with whenever you raise a certain factor to a power, the power will tell you some stuff about the nature of the graph. So, for example, if I just have y equals x minus 4, right? You imagine that's a line that's going to pass through the x-axis one time at x equals 4. It's just going to pass through it. Well, if I square this, right? If I square this, it's kind of just going to touch at x equals 4 and then come back up. So this has a 0 at 4, but it doesn't actually change sign, right? It's always going to be positive. And then you can imagine if I had x minus 4 cubed, you may not be as familiar with this graph, but you can graph it to see that this will pass through as well. So the bottom line is if the power is even, there will be no sign change. And if the power is odd, there will be a sign change. And why is this useful? Well, a point of inflection is whenever the second derivative changes from positive to negative, from negative to positive. And we have three possibilities for whenever it could touch the x-axis, right? We have 0 and 2 and 8. But only the times where the power is odd will the sign of the inflection, will the sign of the value actually change. So that only works for x minus 2, because we have an odd power here to the third, and right here we have an odd number power to the fifth. And so we're only going to have points of inflection at 2 and 8. So if you learned something, make sure to leave a like and subscribe. If you felt like I should have mentioned something that I didn't, make sure to leave a comment, and I'll go into more detail later. Well, I guess I will see you later.